All right. So, my name is Nico, Michael is my partner, and together during the last 24 hours we've built BitSniff. BitSniff, yeah, it's a funny name, is a tool to determine whether in target communications there is present some Bitcoin-related activity. And we do it using only volume over time of the traffic. We don't read any packets, we don't read any traffic. So what does it actually mean? Every time you use any software that is related to Bitcoin, full node, light node, mining hardware, you create a fingerprint within your network activity. This fingerprint is based on small peaks in activity in few seconds after the block is created. And ask me later if you're interested. It's very hard to eliminate. Introducing delays to the system is very problematic. Encryption doesn't fix that. Compact blocks update didn't fix that. And using proper analysis tools, it can be exploited. It probably is exploited. It for sure will be exploited. Next. So in general, what we do, there is some math wombo inside, but we get some network activity logs which someone recorded. Based on timestamping on the blocks, we get actual block times related to the same time area. Based on actual block times, we predict what kind of network activity we expect as a time series. We calculate something like correlation score, and from this we do a z-score, and we estimate the probability of this specific communications being anyhow related to Bitcoin. Next. All right, so this is the performance. We actually recorded 24 hours of our own Bitcoin node communications yesterday, and we tried different window size to try and determine how much time do you need to determine with a high confidence threshold that Bitcoin node is present in the communications. So it starts from about zero true positive for 5 minutes, 10 minutes, because in many of these frames there are no blocks present, and we get to about 70% true positive with 0 false positive for about 2 hours windows. Next. So the two use cases that we thought about, the first isn't actually a use case in our opinion, it's a privacy issue. These kind of attacks can be used by ISP or by government to determine whether you have a Bitcoin node or Bitcoin related activity. It can be used retroactively on data recorded right now in next few years. And in Israel it's not forbidden, but suppose in some country it is forbidden to run Bitcoin node, or you for some reason just don't want to share it with the whole world, then it's very problematic. And the second use case is malicious mining detection. There is a lot of Monero mining malware present because it can be mined on CPU, and Bitcoin ASIC miners exploiting cheap electricity by the government facilities, universities, private homes, anything. All right, next. Where are we?
Demo time.
All right, it's demo time. So we actually implemented the whole system. That's our wraparound. You just drop some network log. Maybe you can show a snippet of how network log looks.
So we will begin with a real network log of 1 hour. Right here.
So we're actually analyzing it right now, real time, and 1 hour is kind of a big snippet because it's very unoptimized in terms of computer science. All right, so what you see is the following. The yellow is the ground truth block times, all right? Every block is represented by a yellow peak. White is communications that you have uploaded. Above you can see our confidence level in these communications being related to Bitcoin node activity or mining activity. And you can actually see that a lot of traffic peaks correspond very exactly to the actual block times. So here we have a near 100% probability score. Maybe we have some example of unrelated data.
You are now in the question time, but you can continue. Judges can stop you to ask questions, but just keep in mind that as you continue now, it leaves us less time for questions.
All right, so maybe we should just show one example of something that is unrelated, maybe the YouTube. So we've recorded several small snippets of YouTube communications.
YouTube upload or download?
Watching. So it's mostly just UTP stream going our way, just to show how different it looks and how the confidence levels just drops to very low values.
Maybe you can start questions?
Yeah, you guys are welcome.
So, yeah.
That's YouTube. All right, so you can see there's a lot of constant data streamline going our way. The value presents big connectivity with 36% probability. Everything below 50% probability means that it's worse than noise, actually. So it is less similar to Bitcoin than white noise, just to get the proportions. Yeah, questions, please.
So, okay, so thank you. You're saying that even behind the VPN, this should look similarly, right?
Yeah.
But we were talking before, not necessarily behind Tor, right?
So Tor does some packet padding and packet rearranging. It would be very interesting to check that over longer periods of time, maybe days or weeks. The statistical significance will go up for sure.
Right. And so, would you consider this to be, I said it in English, I mean, would you consider that to be something you can use to actually accuse someone of using Bitcoin? Is that like convincing enough? Or because I understand that if we look at YouTube data, it looks completely different. But
yeah, so we have a lot of data to show how this confidence level is achieved. But yeah, pretty much. If you set the threshold high enough, whoever checks you, the ISP, the government, they can be like really sure that if they come to your house, you've got a Bitcoin node running in.
Right, and that's assuming though that this is the only thing that's running at the same time.
Yeah, so that's assuming you've got a dedicated Bitcoin machine.
And connection.
If you mix traffic, it gets much harder. Once again, with enough time, those small bumps add up and statistical significance will go up. But these results are for a dedicated machine.
Tried analyzing whether there is some other.
Sorry?
Have you tried analyzing the traffic whether there is some other noise, like some other internet usage alongside the noise?
Yeah, so I actually tried a little bit adding white noise, just white noise of different levels, and that depends of the mean of the noise, of the distribution of the noise, but shielding your communications with noise packets is for sure the way to go if you want to be protected against this kind of stuff. Just you have to do some math because communications cost money.
You can get it from the satellite instead of external.
Yeah. So yeah, mixing stuff is the way to go.
So that would be your proposal for sort of fixing this. Or do you have any other ideas about it?
Well, you know, Bitcoin communications currently are in clear text. So I think from that to get into proposals of how we deal with statistical analysis, there is quite a gap. But standardizing some kind of packet size, maybe trying to distribute more evenly some sorts of communications, except for blocks propagation, maybe the way to go. Maybe the compact blocks improving proposals will get to the point where these spikes get really small. We're just not there yet. All right, thank you.
Thanks.
Thank you.